Welcome to the fourth episode in a series where I'm providing updated information for my DIY PCB tutorial. Well, it took me a little while to get these next few videos out, and I think for good reason. When I started this Addendum series, my idea was to share my experience about making the PCB for my hi-hat pedal, and that was a practical experience as opposed to the little test PCB that I showed in the original tutorial. And honestly, in making a pretty complex practical PCB, unsurprisingly I did encounter a number of issues, which I did manage to work around well enough and was able to complete the project. Anyway, after starting this series, I realized pretty quickly that just discussing the issues and workarounds that I used is not really all that interesting or useful. And I decided to change tack and focus on real fundamental improvements to the process, which is in fact what the last two videos I released have hopefully been. So this and upcoming videos continue with that theme. However, in these videos, I will ultimately be showing you more serious, game-changing improvements to the process. Improvements that should bring radical improvements to the quality, repeatability, and workflow, and something that has literally taken about 3 months of fairly grinding R&D to come up with. So I reckon it's going to be a pretty long and in-depth watch overall, but if you're seriously interested in this process, this is definitely a bunch of videos I would recommend that you don't skip anything. Anyway, let's get into it a bit. Now, I was not really sure where to put this section, so let's get it out of the way first. And I know I just said not to skip, but if you're going to skip anything, you can skip this section. It's mainly just general discussion about FlatCAM. So before we get into it, probably the first thing to point out is that FlatCAM has been a real enabler for me personally, and I think probably many others too. Some really smart people have donated their time to make it, and honestly I'm extremely grateful to all of those who contributed to it. So I think it's really important that we frame any issues that we encounter with FlatCAM exactly in this light. We honestly all just need to be grateful that it exists at all. So keep that in mind as I go into this next part of the discussion, which some might interpret as me just being critical, but really that's not my point at all. The simple fact is that the only easily installable and useful version of FlatCAM out there right now is version 8.994, something that Marius Stanciu from Romania has put together. And it's that version that I've been using, and I can generally get it to do what I need it to do without any major stability issues. So for me, it's been pretty good. However, it's not very stable, and if you try all the various features that it presents, or press certain buttons out of order, it will just crash ungracefully, which is why I pretty much stick to a relatively and simple known good workflow and don't try to be too adventurous. Actually, in a video that I will release in a couple of weeks or so, I'm going to show you how to use FlatCAM's TCL script feature to improve the workflow, a feature that is extremely useful and at the same time just shows how forward-thinking the developers of FlatCAM really were. Unfortunately, with version 8.994, there are so many bugs with the implemented TCL script features, and many necessary features are just not implemented at all, so much so that it's sadly close to being unusable, which really is a shame. Now, a couple of months ago, I actually did head over to Marius Stanciu's YouTube channel, and I tried to reach out to him to get an understanding of the state of development of FlatCAM, to which he promptly deleted my comment. Or possibly YouTube deleted it. It's really hard to say nowadays. Anyway, about a month later, I followed up with a specific question on the TCL script bugs that I was seeing and also the feature set. And for that, he actually did graciously and pretty quickly respond to me. It seems that many of these issues are solved in version 8.995, a version of FlatCAM which Marius has been working on over the last couple of years, if I understand correctly. And it's even something that can be installed in its native Python form today, something his video actually specifically explains how to do. But honestly, the installation process for this is extremely complex, and I don't really think it's practical for most users, which is why most people, including myself, just stick to 8.994, and literally the reason why I've been recommending it too. Anyway, in the discussion with Marius, there was some good news. He did seem to indicate that he was thinking to make a window installer release version of 8.995 at some point, which in theory could be super useful, especially for the TCL script stuff that I was trying to do at the time. Unfortunately, when I queried on the possible timeframes for actually getting that release, I got no response from Marius. So it does not seem like something we could count on anytime soon, but I guess you never know. I also downloaded the source code for 8.994 myself, and I took a look at it to try to understand what the bugs were that I was encountering with the TCL script feature. Basically, I was just trying to make sure that they were actually bugs and not just, stupidity on my behalf. But I can report it wasn't, unfortunately, operator error. To be honest, I would have preferred it with my problem because that would have been fixable. And the reality is that about 50% or more of the implemented TCL script commands that it presents just could never work due to bugs. And they're primarily due to bugs that are related to parameter type mismatching in the code. And this actually tells me a couple of things. The first obvious thing it tells me is that there cannot be any sort of testing regime before they actually release this FlatCAM versions. If testing was done, you would expect something less than a 5% error rate. Well, that's in my experience anyway. The second is that the code structure itself leads itself to being vulnerable to large-scale mistakes that does not get picked up by the compiler. And while for sure the developer is somewhat responsible for this, I honestly think the bulk of the problem is with the Python language that is being used for FlatCAM. Now, Python is an easy entry language, something like the basic interpreters of the 80s that I personally cut my teeth on, but obviously far more feature-rich, including fully supporting things like object-oriented programs, and also offering a lot of other advanced features. And the thing is that a feature of these typical easy entry languages is the lack of strict variable type casting or variable type controls. And that means a variable bucket is just a bucket that anything can go into. Instead of having to deal with dedicated types of, say, number buckets or text buckets or whatever buckets, you don't need to worry about any of that. It's actually a very convenient way of doing things. The downside of all this, however, is that the compiler has no way to help you to know if you're accidentally putting the wrong type of thing into the wrong bucket. And that is exactly one of the big issues that FlatCAM is suffering from. Something that is made exponentially worse by having a mix of contributing developers who have no real reference as to what bucket should get what type of data. Ultimately, I think this is a problem with trying to use Python for a project which has multiple contributors. And this is something that is greatly compounded by the fact that there is no release testing regime in place. Well, as far as I can see anyway, as per the results. Now, I can only assume that it was never envisaged to have multiple contributors when Juan Pablo Caram originally decided to make it in Python. But this is just the way things turned out, right? So it is what it is. Now, I'm not bashing the existence of these easy entry languages like Python, given that using such a language was so critical in my own coding journey. But this also means that I know from personal experience that they do create some pretty bad habits that can take years and years to unlearn. So in a way, there's sort of a double-edged sword. Anyway, try to keep this in mind when you're thinking to bash out your next game-changing Python program. So then, what does it all mean for FlatCAM going forward in relation to the ForOurGood PCB method? Well, if we want to move forward from where we are today, we have to be brutally honest. The simple fact is that it appears that Marius or others do not seem to be motivated to be working on FlatCAM actively. And honestly, that's really fair enough, I think. Now, looking at the source code, I really don't think it's something that I want to mess with either. And finally, there's the simple fact that FlatCAM was originally designed primarily with milling PCBs in mind, whereas my PCB process presents problems that FlatCAM was never structured in a way that it could easily solve them. So my conclusion is that if I want to move forward with my process in a more holistic way, gradually I'm going to have to start moving away from using FlatCAM to prepare my G-code files. And the next couple of videos I'm releasing really equates to the first few small steps in that what is going to probably be a pretty long journey. So I think it's pretty important that we actually talk about where we're at and the specific things that I really want to improve with my PCB process. One thing is the complexity and the time needed to do the preparation of the G-code files in FlatCAM. It wouldn't probably be a huge problem if you only needed to prepare the G-code files once for a given project, but I often find that I need to fix something that I've got wrong in the design and redo the process at least a couple of times for a given project. And honestly, I end up wasting a lot of time. And this is only made worse if I haven't made PCBs for a couple of months, because in that case, I actually have to go back and watch my own tutorial video again to make sure I get all of those little steps right. And this wastes even more time. Anyway, to cut a long story short, I've now implemented automation using a reusable TCL script in FlatCAM that requires extremely minimal setup for a given PCB. And actually completes in just a couple of minutes with just a tiny bit of manual intervention. Anyway, I'm going to walk you through that in an upcoming video soon enough, so hang tight for that. So that basically solved the next problem that I'm facing is with the quality of the result that I get when burning with the laser using my CNC. It's pretty good, but it's not perfect, and it does have some room for improvement. Thankfully, the positional accuracy of the CNC itself is no longer a problem, as I've already discussed in an earlier episode in this series. The problem comes down to the burn path itself, and the level of heat being injected into the work, and even the interaction between the path and the heat levels, all things that can greatly affect the quality of the final result. And if we're just talking about the path itself, we face the problem that the beam shape of these cheap diode lasers is not circular. In fact, it's closer to being oval, with the width being about twice the height. And the reason this is a problem is because primarily FlatCAM does not have the option to set an oval shape when doing those isolation path routing. Now you can always, of course, just set the size of the burn path to be the smallest dimension, be it width or height, but using this workaround has two very undesirable side effects. The first is that by using that much smaller clearing path, it's obviously going to take a lot longer to finish the job. And the second problem is that the result of the Y direction burns will still not be dimensionally accurate anyway, as the beam will actually be burning twice as wide than the path that we actually designed for. And this is going to result in, especially smaller elements, losing a lot of their width. And when we start talking about heat management issues, well, there are literally so many types of causes and symptoms for over and under heating that I'm not even going to go into it in much detail in this video. But there is something important to note that carries on from that oval laser issue that we just discussed. Now, it's interesting to note that if you're traveling at the same speed in all directions, the short and wide beam actually burns hotter on horizontal moves compared to those vertical moves. This is because for the same direction of a burn line, it will typically burn around twice the area of material in the Y direction compared to the X direction, even though the total amount of energy being injected into both areas is exactly the same. Think about it. I think you'll get it. Anyway, this is why you'll often note that the X direction burns look a bit darker or more charred than the burns that are going in that Y direction. This is because it's actually burning a lot hotter when it's actually burning in that X direction. But even so, I think when we talk about heat levels, at least for the case of clearing the etch resist path, it's not a super critical problem. Obviously, it's not ideal, but the copper surface can usually sink a lot of heat. So generally, you can lean a little bit on the hot side, and as long as it doesn't get ridiculously hot, it's going to etch just fine. The two areas where heat management has continually been a big problem for me is clearing the pads of resin and cutting out the solder paste stencil. Put simply, smaller pad shapes end up concentrating the heat much more than the larger ones. So this means that if you try to use the same laser power to clear a fairly large pad on a small pad, the smaller pad's probably going to overheat and fall off the board. Actually, it's a rather brutal effect. And in the case of solder paste stencils, you also get a similar effect, meaning tiny pads spaced close together end up overburning and just making one big hole actually, whereas the larger pad holes will come out just fine. Anyway, at the end of the day, all of these laser-related path and heat management issues are likely things that FlatCAM will never provide solution for us, but at the same time are things that we must absolutely solve if we want to move forward and stop going around in circles, chasing our tails. I've even had a couple of comments in the past tell me that the beam shape problem needs to be solved in the CAM software. I mean, the commenters are absolutely correct. But when I'm reading those comments, I just can't help having it go through my head that these people are clearly stating the obvious. But the thing that they don't say is that there's no such solution that currently exists, and that's really the problem. Finally, other problems that I know that need to be addressed include things like drilling accuracy, making easy vias, and also simplifying and or automating the laser and spindle alignment processes, which are still a little bit fiddly. Now, I do have solutions in mind for all this stuff, which I'm planning to work on soon, but that still will likely be off a little bit into the future yet. Even so, for the drilling and vias, I did actually make a dedicated double-sided test PCB for experimentation, which included specific tests for those areas. And for the drilling accuracy, I tested with a 0.6mm pad and a 0.3mm drill, and without pre-etching those drill holes. And this ended up resulting in an accuracy or a shift of around about 0.1mm for most of the pads. Some of them were spot on, and some of them had the shift. So I think it's really not that bad, and to be honest, I was sort of simply relieved I could even successfully drill the 0.3mm holes without breaking the bit. So we can sort of call it progress, I guess. Anyway, a 0.1mm error on drilling is not really good enough accuracy for me, and I think we would want to see a shift of no more than about, say, 0.025mm to call this good. But even so, I'm relatively confident that I have a plan to be able to get us there. Oh, and my meager effort on making easy vias was a complete fail, which I'd sort of expected. But this was really a secondary issue in this test, so much more R&D is required in this regard. Hopefully I will get there with this one too. Alright, you get the overall picture, right? Lots of things sort of still suck when looking at them with a critical eye. So, in the next video, we will get into the nitty-gritty and I will show you how I worked through these issues and ultimately come up with what is a pretty decisive and relatively easy solution to implement. Well, easy for you at least. Now, I know this is not my usual format where I shove everything into one big video which shows the final result all in one go. And actually, that is the video that I would have preferred to make. And you might think that this is because I'm trying to manipulate the algorithm or do something tricky like that, but it's just not. The simple fact is that making those longer videos are completely soul-sapping to make. Both because they can take up a month of grinding, mind-numbing editing to make, but also because it goes from soul-sapping to soul-destruction once I see the viewership results after all of that effort. So shorter sort of reduces the pain a bit, right? Anyway, I do hope you enjoyed the new format. I think there's generally a lot of useful information in there for people who are interested in this stuff, so I can only hope that such people actually get the chance to see them. Thanks for watching, and I hope to catch you in the next one. So, I'll see you then.